Alright, let's look at 3.4. In 3.4 we're studying some algebraic methods that help us to find the real zeros of a polynomial as compared to imaginary, and therefore factor the polynomial. We begin with the rational zeros of a polynomial. So p of x equals these three factors. So we know that fairly easily we can see 2, 3, and minus 4 are our zeros. Notice those zeros are all factors of the constant term 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. All of these are positive or negative of those numbers. And there's a reason for that, because the rational zeros that make up a fraction or a whole number, they're not square roots or irrational numbers that go on forever, are formed by taking a factor of the constant over a factor of the leading coefficient. So in this one, factors of 2 over factors of 1. Factors of 2 are just 1 and 2. Factors of 1 are just 1. And how many possible answers do you have? Well, you have positive 1, negative 1, positive 2, negative 2. Those are your four possible rational zeros. And so they literally try every single one. You don't want to do this, but they're trying to show you that some of these work and some of them don't. 1 is a 0 and minus 2 is a 0. And so your two rational zeros are 1 and negative 2. Okay. Now again, you list all possible rational zeros and you do synthetic division until you get a remainder of 0. Notice the quotient you obtain when r equals 0. Okay, and you repeat steps 1 and 2, and you stop when the quotient is a quadratic or factor is easy. Use the quadratic formula or factor to find the remaining zeros. Okay, so this one's degree 3, so all we have to do is find one zero and we knock it down to a quadratic. Well, all factors of 6, 1 and 6, 2 and 3. All factors of 2, 1 and 2. So 1 with each one of these is 1, 2, 3, and 6, plus or minus, and 2 with each of these is 1/2. 2 over 2 is just 1, we already have that. 3 over 2, we don't have that yet. 6 over 2 is 3, we already have that. So here's our numbers. There's 12 of them in all. Okay, we try 2. Okay, so you bring down the 2. 2 times 2 is 4. 5, multiply, add, multiply, add, and you get a remainder of 0. Okay? So, here's your x squared, your x, and your constant. You can factor it, and you get your other two zeros. And so you find out your zeros are 2, 1/2, and minus 3. And it factors down just like this. Okay? In example 3, I give you a degree 4, and all factors of 10, 1 and 10, 2 and 5. All factors of 1, just 1. So 1 over 1, 2 over 1, 3, 5 over 1, and 10 over 5. 10 over 1 is just these 8 numbers here. If you notice, you can just plug a 1 in here and see if it works or not. You plug a 1 in there and you just get 1. Plug a 1 in there and you get minus 5, so that's 1 minus 5 is minus 4. Plug a 1 in there and you get a minus 5, so that'd be minus 9. Plug a 1 in there and that's positive 23, so that's 14. And you plug a 10 in there, that's 24. Doesn't work. But if you try minus 1, you can check that one out. And I don't think it works. When we do try it, we get a remainder of 24, so it didn't work. So we try 5. Okay, so plug a 1 in there. Bring everything down and multiply and add, and you get a remainder of 0. So we know it worked. Now notice I don't go back and use these original numbers. I use the new numbers that I have here, ignoring my remainder. Okay, so now I do another one with a different 0, and I try 1, multiply everything out, and I get a remainder of 0. And so this is the quadratic that's left. Right? We had degree 4. And we found 2 zeros, so that knocked it down 2 degrees, so now it's degree 2. Okay, x squared minus 2x minus 1. It doesn't factor, but you can use quadratic formula, and you get 1 plus square root of 2, 1 minus square root of 2. So here are your 4 different zeros. Part B, they ask you to graph that same question. and you get your 4 zeros, you get your y-intercept, and you plot a few more extra points. You look at your end behavior, and you get your graph there. Now there's another thing called Descartes' rule of signs. It can help you sometimes to choose which zeros to try, the positive ones or the negative ones. Alright, so the number of positive zeros, positive real zeros, is either equal to the number of sign changes, variations of sign, or less than that by an even whole number, or less than that by 2 and by 2 and by 2. So look at this. You got positive to positive, positive to positive, positive to negative. That's one sign change. Negative to negative, no. So you had one variation. So there's one positive zero. Now if you plug in negative x, you can see how many possible negative zeros there are. So you plug in negative x for each one, you simplify it, count the sign changes. Positive to negative, that's 1. Negative to positive, that's 1. No. And then positive to negative, that's 1. So there's 3 variations. So there's either 3 negatives or 1 negative zero. Okay? So you have 1 positive and 3 negative or 1 negative. So you're going to have at least 1 negative and 1 positive, or 3 negatives and 1 positive. Okay? So you either have 2 real zeros or 4 real zeros. Okay, so you look at this one. Zeros, they want you to find all zeros between -3 and 2. Well, they try -3, and you get this guy. Okay, and there's a thing called a lower bound and upper bound rule. Here it is. If A is a lower bound and B is an upper bound, right? A is smaller than B, and there's some number C. All real zeros C satisfy this. They're in between your lower bound and upper bound. And if we divide by B, where B is positive, if the last row has the remainder, with the last row and the remainder has no negative entries, so 0 or positive, then the number you just tried is a upper bound. Don't try any numbers larger than that. Now for lower bound, if you're dividing by A and A is negative, notice the lower bound, A has to be, the number you're dividing by has to be negative. For upper bound, the number you divide by has to be positive. Okay, so now if you have that last row, and they alternate between non-positive and non-negative. Okay, so non-positive would be 0 or negative, and non-negative would be 0 or positive. 0 can be either one. Then A is a lower bound, and you wouldn't try any numbers lower than that. So let's try this one. Let's try -3, and we do our synthetic division. We don't get a correct 0, but look, with the A being negative, does it alternate from non-negative to non-positive? So positive, negative, positive, negative, positive. Yeah. So -3 is a lower bound. There's no need to try any numbers smaller than -3. Then what about 2? Positive 2. This could be an upper bound. So we do all our synthetic division. It doesn't work. We get 3, not a 0. But all positives, right? All positive, no negative entries. You could have 0 or positive. Okay? So that means 2 is an upper bound. So for all real zeros, they've got to be between -3 and +2. There's no point in trying 5 or -5. It won't work. It's numbers between -3 and 2. Okay, so now in example 6, they ask you to try -4. And when you do, remember this could be a lower bound, so it's got to alternate. Positive, negative, positive, negative, positive. Remember the 0 can go either way. You can consider it a positive or consider it a negative. So positive, negative, positive, negative, positive. Okay? And so -4 is a lower bound. So all the real zeros are -4 or are larger than -4. Let's try this one. They do synthetic division, they get a 0. Do synthetic division, we don't get a 0. So they use the same number again. Use they do use -1 and they do get a 0. And they try -1 again and they get another 0. So 1, negative 1, negative 1. Sometimes if a number works once, you should try it again just to see if it works again. It can work many times. Alright, so now here's your A, B, and your C. Plug them into the quadratic formula, and you get 3 halves and minus 3. So here are your factors. Here are your zeros. Up here are the all possible zeros you should try. Factors of 9, 1, 3, and 9, over factors of 2, 1, and 2. So you got 1 with each one of these, 1, 3, and 9. And you got 2 with each of these, 1 half, 3 halves, 9 halves, plus or minus. Then number 8, all factors of 3 over all factors of 3. So you get 1 with 1 and 3. You get 1/3. And 3 over 3 is just 1. You already have that. So you really only have 6 numbers to try. So try 1/3, doesn't work. Minus 1/3, doesn't work. 3 doesn't work. Minus 3 doesn't work. 1 doesn't work. 9 doesn't work. Okay? So, what do we know about our numbers here? Well, with a positive 3, we have all positives, so that means 3 is an upper bound. With negative 3, they alternate sign, so that's a lower bound. So we know that it's between minus 3 and 3. And using our calculator, we actually find it's negative 2.3 something and positive 1.3 something. Alright, so in 3.4, they ask you some questions here, and I think they ask you to find all possible rational zeros of factors of 10 over factors of 6. So you get 1, 2, 5, and 10, and then you got with a factor of 2, 1 half, and 5 halves, and 5/6, and you also have it with 10. 11, they ask you to list all possible rational zeros. Then you get all factors of 1 over all factors of 5, so 1 and 1/5, plus and minus. And if you check that, you find out that 1 and minus 1 and 1/5 all work. This one, you're taking all factors of 3 over all factors of 2. So 1 with each one of these is 1 and 3. Then you got 1 half and 3 halves, and they're all plus and minus. When you try it, you get 1 shows up twice, 3, and 1 half. Now how do they know that 1 shows up twice? Because the graph bounces at 1. That's how we know. Okay, in this one, all factors of 14 over all factors of 1, 1, 2, 7, and 14. We tried minus 1, and it worked. So now we had degree 3, so now this has to be degree 2. 1x squared minus 5x minus 14, which factors to this. Set each one to 0, and now you've got your zeros, and that's how it factors. All factors of 2 over all factors of 1, so 1 and 2. I tried minus 1, and it worked. So I throw this into the quadratic, and it factors. Okay, so you've got all 3 zeros, and it factors down to that. This guy, all factors of 8 over all factors of 1, 1, 2, 4, and 8. I tried 2, and it worked. So now I've got it to a quadratic. This is 1x squared minus 4x plus 4. It factors. That gives you 2 as a 0 twice, as well as the 2 that you got before. So it's x minus 2 to the 3rd power. Okay?